Hello, everyone. Welcome to DevProdEng Lowdown, as we call it, DPE Lowdown. It's our first one for the year, and we got an exciting show planned here. Bruce from Gradle. We got also Justin from Gradle, and our special guest here, Nikolay from the Kotlin engineering team. And how this story begins, right? When I met Nikolay was at the Kotlin Conf in Copenhagen. I think that was that 2018 or 19? Do you remember?
I only remember that it was before the
Yeah,
COVID thing.
yeah.
And
After COVID, it was all a
yeah,
blur.
yeah, yeah. It was the last Kotlin conference before the COVID.
Yeah,
That's all I remember. The next one was cancelled.
yeah. So it was probably 2019 ish. And we were talking about develop productivity engineering, and I give you a demo of our stuff of Gradle Enterprise, and we give Gradle Enterprise for free to open source projects.
Yeah,
And and you can go visit that today. We have a slide with the QR code on that. And that's how we kind of started this relationship. And I pinged Nikolay a few months ago. I'm like, hey, let's do a webcast together and share some developer productivity wins and whatnot from his team. And that's where we are today. So let's jump into the good stuff here. First, Nikolay, introduce yourself and what you work on. Let's start there.
Yeah, I'm really excited to be here now. Thank you for having me, Ruth, and hello to everybody, actually, to all our listeners. So my name is Nikolay Krasko, and I've been working at JetBrains I think for the last 10 years already. I was always in Kotlin project, but the set of tasks was constantly shifting. Like I've started more like a developer and Kotlin IntelliJ IDEA plugin, but at some point I did performance optimization both in the plugin and in compiler. And I think somehow I was involved in the continuous integration setup for our project. And about 3 years ago, I became a team lead of a small team called Kotlin Infrastructure. And that's it. That's I believe I'm here right now. May I make another, like a note? I would like to emphasize that I'm here, but I'm going to tell everything about the Kotlin. But JetBrains teams may be completely unalike, and you can spread our experience to other teams because projects are different, and each team is free to decide what practices and processes fit them well in order to be more productive. So there is no common ground in JetBrains. I'm going to tell only about Kotlin. Yeah.
Great. And thanks for that introduction. And it was a great match for us, right? Two organizations where the reason for existence is developer productivity engineering, right? We build developer tools to make developers happier, make them more productive, right? If I had IntelliJ and Kotlin after I graduated computers, I might still be coding right now. It was hard back then, right? And so to tell us a bit more about what's underneath the hood when it comes to Kotlin, right? Our audience is really interested. How do you build Kotlin? What's the software stack underneath the hood?
So let's start from the fact that Kotlin mostly used Kotlin for development. Quite a surprise, maybe. And it used to be a Java project, but now the ratio is about 80-8, according to GitHub metrics, I think. And we are an open source project, and we are hosted on GitHub. You can find us at github.com/jetbrains/Kotlin. And actually, a lot of information can be deduced from the repository itself. Like it's possible to understand how many developers approximately working now in Kotlin. And we can't even hide releases, for example, because we are public and people know already that, when the branch is separated, that the release process has been started recently. So if you continue, Kotlin is mostly a Gradle project and quite a big one. Right now, there are more than 350 models. It's mostly Gradle because we still have Maven underneath. There are about 20 models, and we built Maven plugins from them. So this is all I think about the project. You can find us, you can download us, you can develop in the project, and of course send us pull requests.
By the way, for our audience, right, it's Kotlin's full open source. You can find it on GitHub, and that QR code to the Gradle Enterprise, that you could actually see, hey, how many builds Nikolay ran in the last month, right? and how long they were taking, right? So that's the beauty of open source and the community.
Actually, you won't find it because we conceal it in Gradle Enterprise.
Oh, okay.
sorry for that. So this is not the end. This was only about the project itself, but of course there are more about tooling, and we use a lot of tooling. And here another small note about dogfooding practice, because here JetBrains is not like a random practice, but I would say it's core development principle for JetBrains. This is a practice when you use your own software when you use your services and software to internally. And this is quite a natural thing for us to do because we want to be productive, and we're trying to make tools for productivity for engineers, and we are engineers ourselves, so we want to be productive ourselves. But it can be painful sometimes because, we're trying to use our own software at the very early stage. And if you are doing the infrastructure like me, like for example in our team, like we do in our team, it can be painful. But again, this is well understood in the company, and that this pain is going to be paid off eventually, and you're going to ship a better product in the end. And remember, I've said that each team is independent. This is also a convenient point for synchronization between teams. Like if it's not necessary for the team to use some special software, the team is gonna use our own software, and this way we are doing the deduplication of the work in terms of infrastructure across the team. So this note is quite the list of software is maybe predicted actually. If you know JetBrains products, like we use UTrack as our main issue tracker, we use IntelliJ IDEA like a lot, and we are very active users of TeamCity, and we have more than 100 configuration. I have screenshot about our main aggregate build. You see, we have a lot of split there. So.
And what are we, Nikolay, what are we looking at here on this slide, just for our audience here?
Mm-hmm. So these green stripes is actually our builds, and this is a timeline of our builds, like a Gantt chart.
Mm-hmm, mm-hmm.
So you see, like, I don't know how many configurations are there, but how they're executed. Probably I've tried to make a good one when we put everything in 1.5 hours, I think, approximately.
So this is basically everything that, all the builds, integration to everything that needs to happen to basically build the Kotlin compiler, right? From beginning to end.
No, of course not. This is only partial.
Yeah.
For example, there are many native configurations are not present.
Right.
Are not present there. So
software at scale is hard, right? You're building a product that millions of people are using all over the world, and you need tools and you need the right metrics to look at this stuff, and you need people assigned to this, right? So yeah, very exciting.
Yeah, and this is not all about the tooling we use. I would say that we covered now developer layer, but there is also I would say people management layer, because here we use another JetBrains product, quite a new one. It's called Space, and it's like an attempt of JetBrains to make integrations not only in a development environment, but also at the company level. And here we have information about teams, developers, managers, absences, vacations, and working hours, and so on. Also, what else? A lot of other things, like we schedule meetings there, for example, and we even extend our developer integrations even more with this tool, with Space. We have review tooling, quite a decent one, but we use a lot in our team. And I think also a Git hosting and packaging distribution we have in Space, like a lot of other things. And even now, this list of software is not full, but I think this is a pretty common, like this is the list of software that many developers in Kotlin team are using daily. Some teams using more, like for example, infrastructure team, we need some more for provision, for agent provisions, for example. Yeah.
We had one question that seems somewhat interesting while we're talking about build and test. You mentioned you have, 300 modules. How long
do we want to wait, Ruse, until we want to take a look at the actual performance dashboard? I kind of answered that one in line since we're going to be looking at that data. But we could ballpark it now if you want. We could ballpark it now. The actual question from the audience was roughly how long does it take to build all 300 of these modules and pipelines? And we will have a dashboard that looks at just that. But if you want to give us a ballpark now.
Yeah, this is actually it. This is our main pipeline. Without native that have many additional requirements to the agents, so we do not include this. There is only part of native here, like a sanity test that is executed on a Linux machine, a virtual Linux machine. So we are trying to make everything in 1 hour. So we do a lot of splits in our testing, in our integration testing, but we are not there still. And I don't know what is the actual time for many configurations, because there is also a build queue where we might wait for some special hardware agents and so on. Yeah.
So talking about the team that cares about product or is responsible for the productivity and the experience of all the developers working on Kotlin, and your story is very interesting. It resonates a lot because developer productivity and so developer experience is a fairly new thing. When we started to think about that here at Gradle, when we were building Gradle Enterprise, right, there weren't too many teams that had this name. Google was doing it, right, and it was always someone like you that said, "Hey, I'm really good at CI/CD or builds." And eventually kind of got into that. Tell us a bit about how this team and how many developers you support and how it's structured.
Yeah, okay. As I've said, we are not a dedicated developer productivity team. We are Kotlin infrastructure, and recently we will even build Kotlin infrastructure and did everything about the build actually and our CI, because this is a thing that affected the developer productivity most, because if you have unstable and red builds, you're going to spend time on understanding what's going on inside them. Yeah, and there are 5 of us, 5 team members in the team, and recently it was only 3 of us in the team. And there are more than 100 people now in Kotlin team, and around 80 of them are software engineers. And I know this might sound frightening, actually, because the ratio is, I think, it's quite low. I've seen your previous Lowdown webcast, and I think like that. And especially if I say that actually we do a lot of other things, like we also an input for security issues, and we set up publishing for our artifacts, and actually a lot of more. But this is how this might work and how it works for us. In JetBrains, we have several teams that are working at the level that is below us. Like they work for the whole company and can help with infrastructure. Like there is amazing team of administrators who handle all hardware problems. And also we have site reliability engineers that support a lot of services that are used extensively inside the company. For example, we have a Gradle Enterprise, but we do not support it. We only use it for Kotlin. And also this dogfooding thing is also involved in this infrastructure for Kotlin and for other teams, because we support each other if there are problems with our own software. And this is not all actually. Like we try not to make clear distinctions between developer teams and infrastructure teams. Some developers team here in Kotlin team do their infrastructure for themselves. And this is quite okay. And actually we encourage other developers to improve their development experience, because nobody wants to suffer on their work. Everybody wants to be productive and do some meaningful things. And I'm really afraid of this imaginary world. Like I wouldn't want to end up with this. Our teams, their teams, they shoot us tasks, and we try to understand what they actually is wanted. If you want to be a good infrastructure engineer or developer productivity engineer, I believe that you should know where the points are. And this, how it works for us. We do not abstract developers from the infrastructure and actually try to collect the knowledge and share this knowledge. It's okay if, for example, core compiler team have their own, for example, hardware server for doing some low-level performance tests, because they know what they are going to get and know how to test it and know how to set up it. But if other team in Kotlin is going to have similar server, it's on us to share the knowledge and deduplicate the effort on the cross-team communication.
Awesome. Thanks for sharing that. I mean, we've always very respected your organization. One of the most successful developer tools companies in the world, right? And to sharing how you get there and how you can ship amazing software that fast was very, very insightful. We can move on to productivity wins and whatnot. One of the things that you mentioned was build caching to get faster feedback. And I remember when we first met, one of the demos I showed you is like, hey, let us help you get remote caching and build caching. It was one of the lowest hanging fruits when it comes to developer productivity, right? It's a hard thing to do. Let's talk about some of your developer productivity wins, starting with that journey that we spent together with Etienne from our team, working with you to setting all this up, and share some of those wins and findings.
So as I have said, we are a Gradle project, and we struggled with our pipeline time a lot. We had 5 hours builds back at the moment. So using remote Gradle caches was quite a natural thing for us. And after we met, we actually started this because, in order to set up caches, you probably would need to look at a lot of build scans. And when you have a Gradle Enterprise, it's easy to do so. So we are using the Gradle caches mostly for this split to a lot of stripes. To split configurations. And it's possible to do so without caches, but you are going to build again and again. This is a common pattern for applying the caches, actually. You at some configuration, you build everything up, upload it to caches, and then you run tests and reuse these caches for actual builds and only run tests in the machines. That's how you can save CPU time and can save actually some money. Yeah. And I can say this was an easy task for us to set up caches in our build because, our Kotlin is a big project and we migrated from the Ant recently and had a lot of, at the moment, and had a lot of problems inside the build. But the process of enabling caches is quite simple. Like, I don't know, should I tell about it? Like you have a build and try to build it twice and see if the caches are reused. When you move to other directory, you move the project to the other directory and check that caches are still reused. When you move to continuous integration and check that caches are still can be reused from one engine, produced one engine can be reused on the other engine. And after that, you move back to the local build and check that you can reuse caches obtained from CI locally. There are some additions. For example, if you want to reuse caches on different operation system, and we did it in our build, for example, it was not an easy task either. So that's it about the algorithm. But if you go down to the project, like we had to change a lot of things in our build. There were forgotten inputs and outputs that prevent reusing caches or do the overcaching, like when you shouldn't use caches, but they're still used. And we needed to fixate time steps and file attributes, because if you pack it to the jar files, you're gonna have another hashes and cache will be lost. And we fixed a lot of absolute paths in our build. So it wasn't an easy task. It took us about 4 months, I think, to do this setup. And we still had some problems with overcaching lately, but we need to fix probably even in Kotlin Compiler.
Yeah. And this is something that happens regularly, right? Where, developer, as your code base is growing, there are things that will break the cache and cause cache misses that decrease build times. And we're at Gradle, we're heavily focused on automating ways to find build cache misses and really investing there. Etienne and Nelson and team have done a lot there as well, and there's some really exciting stuff. So to kind of from your side, just to repeat some of the things that you mentioned, because it was very interesting for our audience. You found issues, class path issues breaking cacheability, different JDK versions and whatnot. What was the one that was the most common during this process that you spent with our folks to find things that are breaking? Well, what do you think happens the most? What did you see that happened the most?
Actually, I don't know. Like at some point we fought with like task by task. We fought like with each task individually, and I don't think that there was a common thing. You find something, you fix it, and go to the next one.
Richard Strager, and we have a few questions here that have built up, but I think we can pepper them through some of the other sections. But this one's very relevant. Richard wanted to know, in a little bit of detail, what are some of those root causes? And if I recall correctly from that work, these were things like code that was generating timestamps, for instance, which would then mean that the source code inputs that were coming into the task were actually not matching with what happened on the last run, and so you would generate a different hash key. And then you also had some issues with empty directories as well, and some non-normalized outputs. We have a whole bit of documentation on this, which is our section of like how to debug our build cache misses with task input file capturing, and some techniques for this that we're going to get to a little bit later. So I think we can hold off on it for now, Nikolay, unless there was anything that really stuck out beyond the ones that I just brought up, like timestamp and path normalization issues.
I think that I don't remember exact what was going on exactly there.
Okay, well, Richard,
this was
no, I remember something. For example, there is overcaching problem that eventually happened to be a Kotlin bug, because the caches produced with GDK 1.8 were used when we tried to build the same model with GDK 1.6, and obviously it did not work, for example, because you can't use class files obtained with the later GDK with the previous on the previous JVM. And this is actually a dog fooding thing, because we are doing a Gradle plugin for Kotlin, and this actually plays very nice. And I should say that we are quite satisfied of what we got. We got a more clean build and more predictable build, and probably we would do it later, because now we're doing reproducible builds. And I believe all this work is actually already used in it's actually helped us to make builds reproducible.
And when you did this, we have another question that's in line with what we're talking about right now. Loic, I hope that I'm pronouncing that correctly, wants to know that when you were setting up the build cache, did you end up having to change the Kotlin compiler design to be compliant with the Gradle build cache? Or was it just a matter of turning it on? So there was none of that. It was...
I think nothing like that were present. Maybe I don't remember it. It was mostly about Gradle files and Gradle configuration for the project, but not about the compiler. I think that's...
I mean, the one I remember, sorry to jump, but the one I remember, Nikolay, was that you had some custom tasks that were I recall Etienne had to work with you to set up the inputs and outputs to make them cacheable. But other than that, not much. And it's a good segue to a couple of slides that I wanted to share, Justin, that talks about kind of how remote caching works. When we did this process, and what you all are seeing here, well, on this slide, is this is the Kotlin Gradle Enterprise performance dashboard. You can see kind of it's on this performance tab here. If you go to that QR code that we had earlier, you could kind of get to this page and click on performance, and you put in a CI tag, say, hey, in the Kotlin project, say how the last 7 days here, we're looking at 7 days of data. How was the remote build cache working? This was the thing that Nikolay was really mentioning had the biggest impact, right? And you can see average build time right now for all CI, right? There's different types of CI builds that they run. All CI is around 15 minutes, 28 seconds. We just took this yesterday, so it's fairly fresh data, right? And from the remote cache, they're saving around 16 minutes of build execution time. To get the wall clock time, we divided like actual human wait time. We divided by this parallelism serial execution factor. So average CI build time would have been around 15 minutes plus this 6.79 minutes of wall clock time saving from the remote cache. But what's also interesting, right? You save a lot of money, especially running builds in the cloud. 112 days of build execution time saved in the last 7 days, right? And it's one of the lowest hanging fruits, and that comes back to Loic's question, right? It's not that hard to set up the remote build cache. It's a build cache, and sometimes folks get it mixed up with a binary repository cache, but the results were quite fantastic. And sometimes it doesn't get there right out of the box. So you need to use tools like build scans. And I think we have a nice slide on build scans here, right? It's a free tool that Gradle provides, right? You could go to this QR code on how you can enable it. It works for Maven as well, right? and hey, run my build with a build scan. And you can go to this performance tab of your build scan and the task execution and the build cache to kind of see, hey, how is my build kind of performing? I think we have another good slide on when we looked yesterday, on CI, this Kotlin compiler test had 98% cache hits, saving, I think it was like 1 hour and 15 minutes, this particular build, just from the remote cache, right? And so this build, if you don't get anything out of today's call, webcast for this section, if you have a Gradle project, use the remote build cache and use this free build scan service. As far as setting up the remote build cache, we have a nice slide on what you can do with there's a few different ways to do the remote build cache, right? There's a free version, right? This QR code will take you to the whole remote build cache documentation on Gradle. You can use Gradle Enterprise for a cache backend. You have to build your own cache backend, right? And you want to use the build scan tool for analysis. So you don't necessarily have to buy anything to kind of get there. But managing it at scale is hard, and that's why we use Gradle Enterprise for the dashboards and whatnot.
And to your point, Ruse, we've got this article right here, which I'll paste a link in. This answers a few of your questions about, what are some specifics about the techniques that are used to optimize, the build cache. Some of these specific scenarios that we were talking about earlier, they're very well documented.
Yeah, we have a nice
solutions.
Slide here on task input file capturing, and for folks that want to dig deeper into debugging build cache misses, this is how we do it, right? The demos are with Gradle Enterprise, but it's essentially, hey, you run a clean build, seed the cache, don't make any changes, turn the build cache on, run it again, and everything should come from the cache. If not, why not? What is happening? What tasks? And you can look at build scans to see the 2 build scans to see, hey, what tasks are running that should have came from the cache that are not, right? So you can do this without, you can do this with build scans, and all that is in that tutorial. And that should answer some of the folks' questions around build caching. While we're on, any other interesting wins from your side that you got from build scans in general, Nikolay?
I think we do not use a lot of Gradle Enterprise features right now. For us, it's only a bunch of stored build scans. And the usage of those build scans is not distributed evenly in the Kotlin team. Like our team, looking at them in case there are problems. But usually we're starting from TeamCity, actually. And if it's if it's possible to understand what is going on with the build, we end up there. It's still very convenient to have build scans from on the CI, and they should be collected unconditionally, because if it's not possible to understand what's going on from the logs, actually, it's very convenient to have a build scan. Usually for us, it's performance investigation. We also have another team that is called Kotlin Build Tooling. They're responsible for writing a Gradle plugin for Kotlin. And of course, they use build scans a lot because they need to understand what's going on with the caches. And for example, they sometimes need a series of build scans from local machines to understand what's going on with incremental compilation for Kotlin. Yeah, other than that, there are a lot of, I know that there is a lot of analytics obtained because you collect a lot of build scans, but I would say we do not use it. Yeah.
So you're mostly using it for build performance and when stuff goes wrong in CI where the logs aren't helping you. And that's what we see as well, right? You have the develop productivity, the platform folks that actively use this for performance profiling, but developers don't really care. They want the build to work. They don't care, right, about the build. right? Unless stuff goes wrong, right? And that's very helpful. Moving on to more developer productivity wins. You were telling us a very interesting story of your whole pair code review practice and the impact. Why don't you share that with the audience?
Yeah, actually, I would like to promote this pair review practice because it worked well for our product, for our project, for our team, for Kotlin, and we use it extensively. And this is a pair review when author and the reviewer are actually doing review together. They might be sitting at the same desk, for example, or be on a call with screen sharing, or even use some more advanced tooling like, for example, Code with Me. And I would gonna to compare this to the what I call a normal review practice, when you upload the changes that you want to be reviewed to some tooling, and after that you just waiting for the verdict and the comments. So this peer review practice was introduced at the earliest days of Kotlin. At some point, we decided to add a review to get the advantages of review, like code sharing and having another opinion before committing the code. I think it was brought by Andrew Bristow, the creator of Kotlin, to our team. And quite interesting, it was like we didn't want to attack developer productivity too much when we introduced this practice. And it can be quite illogical because now during the peer review, you have two developers are involved simultaneously in the review process. But during the normal review, only one developer is busy at the time. How can you be more productive here? But what we found that the most time is spent by reviewer on restoring the context. If you want to do a good review, actually, not just click the accept button, you need to understand what was the task, what was the context of the task. You need to inspect code not only from changes, but actually a surrounding code. And actually, this all information is already in the head of the author. You can just ask him and even ask questions and get a better understanding and get it faster and be prepared for the meaningful conversation faster. This is how you can speed up the process, actually. But that's not all. And it's kind of magic-like. It's kind of magic because for a reviewer, everything is also changed. Actually, when you do this practice and try to explain how your code works, you actually do a review for yourself, and you can go from the tunnel visions that you might have while you were solving the task, the developer task, and you can see the reactions of reviewer, and it's like another input for your task. For example, you might expect that some code is obvious, but you can see that it's not that obvious. And there were many situations like reviewer was quite okay with the code, but the author was not happy right on the review and suggested some corrections. And sometimes it was the author who found all the bugs and suggested another round. And this is not all about the practice, because of course when you do trying to adjust the code together, you're also sharing the experience and expertise in tooling. Like, hey, I didn't know it is possible to do that in IDE, or did you thought to make this same task faster with, for example, with some refactoring or using the multi-caret thing or something like that. Yeah, and
we have one question from Vinay specifically about this pair review process. Vinay would like to know, did you have to schedule this work in advance to do the pair programming, or was it more of an ad hoc thing? Vinay wants to know how it affected like the other person's schedule when they were pulled into a pair review.
Very good question, actually, because this is a main disadvantage of this practice. And actually, I believe it's killing this practice, because there are human interactions, and sometimes it's difficult to find the time slot if you are busy, or for example, if you are not in the mood to tell stories or to listen stories, you would prefer to make in the old way. And of course, if there are tensions between the author and the reviewer, it can ruin the thing. But previously, when we did not have a tooling for that, this was actually an essential thing to do. We need to find a reviewer and ask him for review. And this was the time we were trying to find a slot. And it can be seen as an advantage also, because you know exactly when the review is going to be done. And you can plan, and you can actually understand better what is going on.
And one more follow-up question to that. I think people are very interested in this process. Stefan would like to know whether you actually change the code directly together as well, or if it's just more of a review. Are you fixing things during that review?
This is another advantage of this practice, because often if you do it fast, if reviewer is ready to react right away, author probably have prepared setup for this particular task and actually show how these changes are working. And it's more not like a review, but asking for an opinion. You can show what other approaches you have tried, for example, and show it in a live. And if it's possible, it can be changed right away and spare you another code review round, actually.
No, that's super interesting. Thanks. Yeah, I mean, I think we have several comments that this pair review is like very, very interesting. We're seeing a lot of that, so might be something to do a follow-up blog on, or if we have any other materials, we can send it after the show that you know of. I think people are very keen to learn about this practice.
Yeah. I'm a big fan of this practice, but there are no blog posts. Unfortunately, this is my, there is a follow-up for that, because when we got a decent review tool we didn't have previously, but now when we have space with a lot of integrations in it, like you have not only changes, but information about the CI status also collected there. And you space can actually give you an advice who should review the code. We have a code owners feature now. There are too many incentives to create review in the tool. And after it's created, I see that this practice is slowly declining, and more review became the normal review, not the peer review. Like people tend, with the team grow, people tend to forget about the magic and try to avoid maybe interacting with other people. And you can't actually force people to communicate. I can only try to persuade people to use that, and I'm trying to persuade our listeners to use it, because I think really that it can be very useful.
And we got to wrap up the Q&A soon, since we're running out of time. Just a few. I want to get through some of these follow-up slides as right before we do Q&A, as we're running out. So one interesting thing here for us is this maturity model. It's a very interesting piece of content. You want to quickly talk about that, Justin?
Yeah, thanks. Yeah, this is a pretty exciting piece of content. It's pretty new, and it is very complementary to our DPE handbook, which some of you are probably familiar with, which is in its second edition. This takes a lot of kind of the lessons and techniques, and I would say even, cultural aspects of DPE, and kind of puts it in sort of a rubric model where you can take sort of an honest look at the practices that you're doing with respect to productivity and with respect to developer productivity right now today, and figure out where you are kind of in this spectrum. And then that'll give you some really nice rails and guidelines and techniques to be able to kind of move to that next level of maturity with DPE. So it's a really good way to just kind of assess. You can do it as a self-assessment. You can work with a couple of team members if you need to, but just kind of go through this. It's going to establish kind of what level of maturity you're at right now with DPE. And then again, how do you transform current practices to move to a more mature DPE model? And with it being such a new and emerging practice that was really only starting to crystallize 5 or 6 years ago at this point, people have really commented on how this is a really useful sort of normalized guide to give people sort of a good starting point. That's this recommended based on what we've seen, how we've seen organizations really adopt this practice at scale and with a lot of success.
And I think we're getting close to this wrapping up time. There is you can go to Gradle community Slack to continue the conversation with Nikolay there. And maybe we'll start Justin, you could start a thread with Nikolay so we can kind of get some other of these questions in there. Also wanted to kind of share that, thanks for JetBrains and the Kotlin team for allowing Nikolay to spend some time with us and share these wins and findings. You can follow them on Twitter. They have some really interesting content on their YouTube channel, right? He has a nice video about multi-platform. I know I'm hoping we get to that, how open source can help with the community, can help with Kotlin multi-platform. Hopefully, Justin, we have a couple of minutes at the end to do that one live, because I think that's
there are two super interesting questions that I really hope we get to. So yeah. And
then this link will take you to that Kotlin multi-platform video that you and team really wanted to share with the community, Nikolay, right? And you can meet us at the Gradle booth at Kotlin Conf. It's in Amsterdam, April 12th to 14th. Gradle is a sponsor, and Justin and team will be there. And yeah, let's see. We got 5 minutes so we can all get to our next meetings, right?
So let's jump on the easy one first, because I really like the spirit of this question, and I don't think that we're the full quorum. In fact, I know we're not the full quorum to answer this, but I'm super interested in people's opinions. So the question from Ahmed is, with Gradle adopting the Kotlin DSL, and then with Kotlin kind of and just sort of Kotlin more and more, we're improving plugin support and everything like that. We're wondering, the question, and this really is more on the build tool side of the house, just to be perfectly frank, but the question is Gradle pushing for it? Or is Kotlin really helping to fill a gap for the community in kind of, where is that balance between how Gradle is thinking about this relationship and how Kotlin is thinking about this relationship? And I have my own opinions on that, but I would love to hear Nikolay and kind of his thoughts about how we, really how are we working together? Is it that, we're fans of each other? Are we working to serve the community? Is it some combination of both of those things?
So first of all, as a build engineer, I'm pretty happy with Kotlin in Gradle because it's make our life easier. With you can use completion, you can see the compiler errors, and this changed the experience dramatically. I believe so, and I use Kotlin a lot, and Kotlin scripting, I love this one. And in terms of sharing responsibility, I think that all Gradle DSL is done by Gradle, and on our side is building the tooling for compiling and having everything work in IntelliJ IDEA. So this is how we divide the responsibility. Please tell me if something is...
No, I think I would just add from my side, I think a spirit. I mean, and I think we kind of touched on this at the very beginning, but we are in the same business, right? One of the things that's so beautiful about Kotlin is that you can have all of the full power of the Java language, and you're typing so many less characters, right? You're literally toiling less to produce the same, and for those of you who may not be as familiar with Kotlin, it's a really fun exercise to actually just go and write a bit of Kotlin, compile it, decompile what you created and see what the Kotlin compiler actually put in place for you in terms of native Java. And you look at this a couple of times, you're like, wow, that is like way less. And, I mean, Gradle has always been in the business, and Gradle Enterprise, of course, is in the business of reducing overall toil, making developers be able to stay in their state of flow and just literally have to do less work to accomplish the same thing. So I feel like why we're here, like our missions and our spirit is very much aligned. And I think because of that, there have been so many opportunities for our communities to work together, is I think how I would answer that question. Ruse, what are your thoughts before we get to the tougher question?
I'm not going to speak for the Gradle build tool team, but I'll tell you all this, that if you go to Gradle community Slack, right, great resource. I know I'm heavily promoting this. Is free. Go in there, get free support, guys. But there's a Kotlin DSL channel where you could throw your questions in there. On Gradle.com, we have free training on Kotlin DSL. So if you want to dig deeper in those, ask the folks that are working on it. I know Paul, Rodrigo, if you have a few folks, and they're all very responsive on this Gradle community Slack. I would recommend that.
No, that's great. Thanks.
3 minutes. Let's take one more.
Yeah, let's take this one. All right. So, Nikolay, people want to know your opinion on multi-platform Kotlin, and specifically how the open source community can help with that effort.
I'm not sure I can handle this one because internally we are not doing the multi-platform. This is actually the place where we do not have much dogfooding, and especially in Gradle infrastructure and in Kotlin infrastructure team, unfortunately. So I don't know how it's.
Where can the audience go to see how they can help and contribute? Where would you recommend them to go?
So we have a public issue tracker. And also there is community Slack. I don't remember the exact, like it should be Kotlin Land or something like that.
Justin, one more, 30 seconds.
Sure. What about any dependency related wins that you can recall with Gradle Enterprise, whether understanding the dependencies through the build scan or maybe optimizing them through the performance?
Yeah. This is another sort of task we do it with build scans, because it's possible to collect the dependencies from the logs. Like I think you enable the dependency task and have as a full collection, but it's also very convenient to do it from the Gradle build scans, because they are all listed there and you can search it from the UI. So if you want to investigate how something is going to end up in our build, we usually do a build scan and see how it came and what was the library and what was the path that required this particular dependency. Yeah.
And that's all exportable too through the export API, which is super convenient. So you can actually pull that into another interface if you need to.
Yeah, and we're working on some content around that. Really interesting stuff there. Okay, folks. Once again, thank you, Nikolay and the Kotlin team and everybody at JetBrains, right, for being such great partners to Gradle, right? I know Hans would definitely want me to reiterate that, thanks for spending time to share with our audience what it takes to ship software at that scale that's used by millions and millions of people all over the world. Thanks, Justin. Thanks, our team and streaming team. With that, we'll say goodbye and see you all next time.